So today we are going to perform a class 12 experiment that is based on half deflection method. We call it half deflection method. Okay, and in this experiment we will find the internal resistance of the galvanometer and also we will find the figure of merit. To perform this experiment we have connected this eliminator battery and a big resistance, and this resistance is adjusted in 6000 ohm, a very big amount, and the galvanometer, all the three instruments are connected in parallel. Now you can see here a small resistance is also there. It is connected in parallel with the galvanometer, but the key is, now I will open the key. Okay, so since the key is open, so this resistance is out of circuit now. Now someone please switch on. So we will see, observe the deflection in the galvanometer. Now when the switch is on, we can see the deflection in the galvanometer is 25. So write it down, deflection in the galvanometer. Please switch on, switch off. So deflection in the galvanometer is 25. Now we will include this small resistance by putting the key on. So now this time the small resistance is included in the circuit, and we will adjust the resistance of this small resistance so that the deflection is half of the earlier one. So earlier one was 25. Now we need 12 and a half. Okay, so we will adjust the resistance of this small resistance box so that the deflection produced in the galvanometer is 12 and a half. Okay, so we have adjusted the resistance here 100 ohm. So please switch on. So when we switch on, we get 12 and a half, our desired result. Okay, now see what is the resistance of the small resistance box. Okay, so it is 100 ohm. Okay, so the instrumental part is over. Now we are going to the shifting towards the calculation part. Okay, now my resistance of the big resistor is 6000 and the small resistor is 100 ohm. Okay. Okay, now switch off it and we will go to the calculation part. First we will find the resistance of the galvanometer. So big R, capital R is 6000 ohm, deflection is 25. Okay, and small resistance S is 100, and the formula for the galvanometer resistance is R into S divided by R minus S, and putting these values we get the value of the galvanometer resistance is 101.6, and it is accurate enough. And then we will find the figure of merit. So figure of merit for this galvanometer is I by phi, and the formula is again K is equal to E divided by R plus G into theta. So every value we can put here. For E we have taken a 2 ohm. 2 ohm is in operation, was in operation. Okay, so you can see here 2 volt. So for E we will use 2 volt. For capital R we will again use 6000, and for G, which we have calculated just now, that is 101.6, and the deflection produced is 25, and that is written here. You can see it clearly. And after calculation we get the value of figure of merit is 0. Continuously 40, then 1311. So this is the figure of merit of the galvanometer. So this was one reading we have taken, and similarly we will take a few more readings by adjusting the resistance of this big resistance box and simultaneously adjusting the resistance of the small resistance box, and we can get few more readings. So this was the procedure how we find the resistance of a galvanometer and its figure of merit using half deflection method. Okay.